can we go? So this is what I
એક
wanted.
નવા પ્રકારની વાર્તા કહેવાની સુવિધામાં આપનું સ્વાગત છે, જ્યાં કલ્પના નવીનતાને જોડે છે. તમે જે જોવા જઈ રહ્યા છો તે સંપૂર્ણપણે કૃત્રિમ બુદ્ધિમત્તાની મદદથી બનાવવામાં આવ્યું છે. દ્રશ્યો અને અવાજથી લઈને વાર્તા સુધી દરેક તત્વ એ દ્વારા ઉત્પન્ન થયું છે. તે ફક્ત ભવિષ્યની ઝલક નથી, તે આજે ભવિષ્ય કેવી રીતે બનાવવામાં આવી રહ્યું છે તેની એક ઝલક છે.
So now if you have a mic, you can talk to this and essentially you can ask any question. So essentially what you have is digital humans following you around. So, and it's pretty easy to make, and what we wanted to show is we have abstracted all these nuance, and these workflows are available for you so that you can just take your video, just take your audio, run one line of command on your laptop, or if you have a server farm, if you want to scale it for millions of users, and you can run it basically for any of your use cases. So this is one application I just wanted to talk about. I think we have spent some time.
With AI and automation. With AI and automation.
So this is what I'm going to show you, and you all are welcome at our booth at Bharat Pavilion. So this is also something that we are demonstrating. So what I'm going to show you, the background music, every frame of it has, and the voiceover, and in 11 Indic languages has completely been created using generative AI. So this was a model that got released in March. This model is called Cosmos. And if you guys are interested, I'll be giving the package for how to create these type of solutions at the end of the session. You can connect with me. I can just give you a link. You can download it, and you can build such videos from scratch. And you'll also have the manual in that package as well. So, thank you.
નમસ્તે, इस सम्मेलन में आपका स्वागत है. વાર્તા કહેવાની એક નવી રીતમાં આપનું સ્વાગત છે, જ્યાં કલ્પના નવીનતાને સ્પર્શે છે. તમે જે જોવા જઈ રહ્યા છો તે સંપૂર્ણપણે એઆઈની મદદથી બનાવવામાં આવ્યું છે. દ્રશ્યો અને ધ્વનિથી લઈને વાર્તા સુધી દરેક તત્વ એ દ્વારા ઉત્પન્ન થયું છે. આ ફક્ત ભવિષ્યની ઝલક નથી, এটি একটি তৈরি ভিডিও. এটি সংস্কৃতি, ভাষা, ধর্ম, জাতিগততা, ভূগোল এবং ঐতিহ্যের অসংখ্য মাত্রা জুড়ে বিস্তৃত, যা পরিচয় এবং অভিজ্ঞতার একটি সমৃদ্ধ. ইন দ্য কার্নলি इंडियाविन कलाचार पन्मुगतन्मये काटगिरद. आमच्या बूथला भेट दिल्याबद्दल धन्यवाद.
Those humans which you are showing, are they for real? They exist somewhere?
No. These are all generated faces.
How guarantee is that? I mean, I have seen some ads in my own company, we do it, but I'm not convinced that they are generated people, you know. I mean, we're using all kinds of tools.
Yeah.
But how can you guarantee that some, and also there is a saying that there are 7 people look like you in the world. Somebody, what is the guarantee they're not going to come and sue me that, you know, you use my face?
Sure. So what we have done, there are studies, again, like it understands. So generative AI, again, it's not magic, and it's not taking someone's face, putting it and creating a nightmare in terms of IP infringement. So how these models work, you write a text. So let's say I'm generating a video frame for a Himachali man. So the AI model, because it has been trained on entire internet's data, so all YouTube data, whatever is copyrighted and has been licensed, the model gets trained on those data, and it understands that nuance. So there's something known as the clip encoder. That clip encoder basically it maps your text to your input, your image or video. So that is done in a different dimensional space called the latent space. So these are all number representation. And then there's a part which basically this appears to the second part of the model as a noise. And from that noise, it denoises it and creates that representation that you're seeing. So it has understood the nuance of how a Himachali man looks, what are the features, what the dress would be like, and from that, it is generating a representation, and it is not actually spitting out data that it saw during the training. It's amalgamation of all the features that it saw during the training, and it learned that how a Himachali man typically looks like. So if you're, yeah.
So mixed match,
Can an answer to this question be that you get a competing AI solution to verify that it's not
It's a,
fake and not representing a real person?
and exactly, we also, so we do create.
You know, if you get, say, Grok to verify that an image generated by ChatGPT
Mhm.
is not truly representative of a living person,
Yeah.
you can ask that prompt and maybe it will give you an answer.
And
That's
that is absolutely solved. And if you go to build.nvidia.com, we also have demonstration for deepfake detection. So there are models, there are competing models, because underlying, it's not magic, it's just maths. So underlying, there are signature via which you can identify whether these images are AI generated or are real images. So a lot of your metadata also goes in, how the image is generated, the pixel pattern. So there's signature which tells you whether this is a AI generated image or it's a actual representation of a person. So we can also show a demo that's hosted. So there's a link that you'll always see flashing at the top. So if you go to build.nvidia.com, so there's a deepfake detector as well. So you can try it out yourselves. You upload your image, you upload a generated image, and you can verify the outcome. So because we understand these IP infringement challenges will come up, there's also solutions to verify that how these images, whether they are created images or they are actually some living representation. Actually, it's a representation of some living human out there in the world.
Just one question. Now, these are NVIDIA's models, right?
Yeah.
That are building this.
Hmm.
Similarly, okay, there are competing players who provide this tech as well. Do you provide indemnity that this is a generated model? This is not indemnity. Yeah? If someone sues against me that
No,
this
that's
is my-
again at the end of the day lies with the users. They have to, because a lot of platform has made it a requirement that you have to tag that these are AI generated images.
I'm speaking about, is there an indemnity? No.
Not on the model creation part. So
No,
you are
not the
free.
model creation, not the final
The final output.
final output using this model that yes, this is means if someone sues me, you indemnify me.
So it's again like it's
There is a competing player who does that, which is why I'm asking whether they
sure.
do it or
So
not.
I'll just again have an analogy for this. So you can imagine like I'm a paint manufacturer. You can use it to paint your house or deface a wall with a graffiti. So should Asian Paint be sued for it? Yeah. No, that's the analogy. So that again remains with the end users to declare that it's a AI created video or AI generated image. And there are certain platforms that demands it. There are certain platforms where you can pretty much do away and do not have to declare whether it's an actual image or AI generated. But nothing enforces at least the model builders. And we are not again competing with the Groks of the world or the chat GPTs of the world, because what we want to do is we want to democratize the tech. And we are a platform companies. We work heavily with OpenAI. We work heavily with Meta as well. What we are showing is by creating these models, we can understand these workloads and make our hardware also better. It's kind of dog feeding. We are doing fundamental research, dog feeding, and also enabling the ecosystem. So that's a three-way thought process that NVIDIA has. And because it has some of the best researchers in the world, we come up with models that are oftentimes, if you see, there are leaderboards and you'll find NVIDIA models at the very top. And our philosophy is we'll just open source everything because we believe open sourcing stuff will enable more and more people adopt this tech and eventually drive the entire ecosystem. This is all open source. And at the end of the session, this is the exact demo how this was created, the Docker container and all the scripts that you need to do that, I'll be giving it away. So you can, like if you have a server grade GPU, you can run it on your GPU, or if you have like a GPU on your desktop, you can do the same thing. These are pretty lightweight models, so I kept the audience in mind and I created a package that could be run essentially anywhere. So you can try it out and create videos like that for any of your use cases. Okay, now coming to where does these all things tie in? Image generation and video generation is good till a point. I can create my own content, but is there a bigger vision behind it? The answer is absolutely yes, there's a bigger vision behind it. So what we, as a company, envision that, okay, now everyone, something like a grok comes up, nobody is impressed anymore because we are now quite used to it, that this has become the de facto standard of search or how we operate. What is the next big thing that we think would be coming? So for us, from where we stand and how we see the industry, for us, it seems that physical AI, the embodiment of intelligence in a robot, is where our society is headed towards. So using this image gen, so you can understand that ChatGPT becomes like the speech part of the mind. These audio gen models and everything is part of a broader section of intelligence called cognition. So there are image gen models. So why would an image gen model be part of cognition? So let's say you are building an autonomous vehicle. You have to train that algorithm, but do you just drive the car around the city and capture all possible circumstances? Because the events that you're trying to prevent maybe are one-off events which are impossible to capture. And if the model has not been trained, these are all probabilistic model, you never know how it would react. So you can use technology like this to create very photorealistic representation of your surrounding, of how a car is being driven. If there is an accident, you can attach a physics engine with it. NVIDIA also does that. We also create the physics engine and simulate the outcomes very accurately. And that data, what we generate, gets absorbed back into the pipeline. We train the models, and the models keep getting bigger and bigger. So the broader vision is, yes, we want to enable content creation, and also like people who are working in the creative industry, they take away value from this. But as a bigger vision, this is also the reason why we do this research, to make sure the AI that we are seeing getting deployed all around us becomes safer for everyone. And that is how NVIDIA envisioned the future is going to look like. So there are going to be server farms where you do the training of these models, because these models, so we imagine the world to have like 3 types of computers in the future. One, the typical data centers, which are getting more and more popular these days. Companies like Meta, Amazon, they are building it. So all your Claude, Anthropics are being built over there, ChatGPT. So everything is running in a server farm. It is being trained there, it is being deployed there. But is that enough? Once you have like a humanoid, where do you train that? And humanoids are not something that are things of future anymore. They are being deployed in factories, even in India. There are factories where there are humanoid workers working across the factory line, and this is becoming more and more of a reality. And that part, for that we have something called the Omniverse platform. What you do is, you can imagine what comes out of a data center is like a new college grad. Once you have all the knowledge, but you have to basically prime it for some purpose. And that is what is being done in NVIDIA Omniverse with Cosmos. So there we'll essentially train the humanoid how to react in a simulated setting. So you can run like 15,000 hours of run maybe in a minute. So you crunch the timeline, all the learning is crunched up. It learns how to do its task in a given set of environment, and then it gets taken out and deployed on the AGX platform. So AGX platforms will be where humanoids, your autonomous vehicles, these things would operate. And these solutions needs to be low latency, because you want the autonomous vehicle or the humanoid robot to react in an instant whenever there's a one-off incident that is happening. You have to prevent that. So that's how the world from an NVIDIA's lens, we envision the world is going to look like. So it's going to be like a 3-computer world, one to train your intelligence, one to prime it for your use case, and one to deploy it and run it in the real world. So how this has been trained? So the Cosmos model that I just showed you, so it has been trained on 200 million hours of video. And what we are showing you is we are just giving you an estimate of if you want to train something like this is the amount of data you want to collect. But let's say you have a use case for it and you want to take our model, since it's an open source model, and adapt it. Let's say you are a content creator in Kerala and you want to capture the even finer nuances of the Malayalam culture that is there. You don't want to start training from scratch. You just take our model, fine tune it, and get started with it. And how to do that? We create these model open sources. We understand that these are technically very complex problems, so we open source even these recipes. So these recipes, if you are interested, please connect with me. I'll help you share the resources. So these recipes are again available online, free for everyone to use. You just plug it with your own data and you can fine tune it for your specific use case. If you think the model that is coming from NVIDIA out of the box is not sufficient for your particular use case, you can always bring in your data. A few hours of video is good enough to prime your model for the use case that you are thinking about. But to train from scratch, this is the level of infrastructure that you are looking at. So 20 million hours of data you have to scrape, 10,000 NVIDIA H100 GPUs. Till the last year, they were the best GPUs on earth. Each of the GPU would be about $5 million. So pretty expensive system if you want to train from scratch. But if you want to fine tune it, then it's pretty cheap. Yeah. These are data center scale GPU. As a gamer, I'll probably not be using any one of them. So these are all data center grade GPUs that you're seeing. So 2,000 hours of training. So imagine the amount of data. So doing this, only tech giants who have incredible resources, essentially limitless resources, can do that. Not this one. This is a video gen model. DeepSeek, again, DeepSeek is a pretty interesting case. DeepSeek, they did not train for $5 million. They converted that model to a reasoning model in $5 million. And what they effectively left out is the synthetic data generation. And there's a lot of nuance to it. Just converting it to, I'm not denying the fact that there were novelties not involved in that. There were novelties in terms of GRPO and your reinforcement learning policies. They did a good job, and again, necessity becomes the mother of all invention, because the amount of export control that China is facing right now, they have to do very innovative things, and that is what exactly they did. But these are very heavy video gen models. Like generating text is an easier task. Like generating text itself is very difficult task, but compared to what I was just showing you is incredibly easy. These are even more complex systems. So we do not recommend anyone to train from scratch. First, take these models, evaluate them. If it is good for your use case, just run with that. If you think you want to fine tune it, maybe a couple of GPUs that you have lying around, it's good for, you can fine tune using that. Because fine tuning is not that resource intensive, whereas pre-training from scratch it is. Because you have to.
Fine tuning, you mean using RAG?
No. So RAG essentially is connecting with your knowledge base. Yes. When you create a RAG pipeline, you do not retrain a model. What you do is via zero-shot prompting and few-shot prompting, you give them the data back and just tell, based on what I have given you, generate the answer. So it is not learning anything, but fine-tuning, essentially you are playing with the model's weight and resetting some of the weight so that it is adhering to your instructions better. So that is what fine tuning does. Not touching the billion parameters, some 10,000 parameters will be changed and learned, and you're good to go. So that's the difference between a RAG and a fine tuning approach. So right now, of the three-partite world that I was discussing, the first one is what I showed you. It's out in the open. The second one is also out in the open. You create a digital human and then do a style transfer. Very good for creating digital humans for gigafactories, or let's say if you're a architecture company, it's super useful for you. You can do very realistic rendering, and just via prompt, you can start creating worlds inside our Omniverse and Cosmos platform. Now the reasoning part, that is also coming out in the next few months. We are doing some internal testing and benchmarking. So once that is out, basically these video models, you can throw visual reasoning challenges at it. Just like moving around a dice and figuring out where the dice is, under which box, or giving it complex visual challenges, like fixing a jigsaw puzzle, which for a human being, it's pretty easy, but formulating that as a mathematical problem is an incredibly complex problem. And that is solved, and we are now just doing some internal testing. And in a month and a half time, the visual reasoning models will be out. And I'll also be showing you the reasoning capabilities of some of our models. Some of the models that we have, we are showing as a part of our booth, where we are showing that if there's a basketball game happening, and you just write tip-off alert and basket alert, what it does is, as the stream is happening, whenever there's that event, it cuts out that video, creates a caption, sends out it to your social media platform of choice without any human intervention. So that is what can be done right now. You replace basketball with cricket, it does the same thing. So if you are a broadcaster, I think this stuff will be pretty useful for you. And that is something that we are demonstrating at our booth. And that is something I'll show you here as well. So I have created a tip-off alert and a basket alert. So it is giving you, the first task I asked was analyze the game frame by frame and tell me what is happening. So first it gave me the analysis. Now it is cutting the clips. And whenever there's a tip-off, whenever there's a basket, it's also creating the caption and keeping track of the score as well, who's leading when, and it is giving you the exact scores along with the social media post. Everything is automated. This is part of that. So we have a model called Villa, again open source. This entire blueprint actually is open source. So if you want to do something like this, what can be another possible use case? So something that Adobe is also demonstrating in their booth, the Firefly, where you're a content creator and you have like petabytes of video frames lying with you, and you're looking for that particular frame. How do you sift through the massive amount of data that you have and find that frame that you're looking for? You just type it in. You just type it in and you'll find out that frame.
Prompting is important there.
Yes, it's becoming the new Google search. Prompting is essentially becoming new Google search. And not only you can relate the data, you can actually ask questions. Did player X score a basket? And it is giving you answers. Yes, this player, he did score a basket, and it is also giving you the timestamps as well. So this lag to answer, so we have two kind of latencies. One is called the time to first token, and the other is called the inter-token latency. So time to first token is essentially from the point I understand the question and start answering, like the first word that I utter. So time to first token is in the range of 1.2 to 2.8 seconds before you hit enter and the first word appears. And the inter-token latencies are lesser. The inter-token latencies are somewhere like 60 milliseconds. After the first word appears, the subsequent word will appear in another 60 milliseconds. So that's the latency you're looking at. And this video has not been sped up at all. So what you're seeing is, I can again play it so you can get a feel for that. So it ingested the video. You hit the summarize button, it starts summarizing. And once you start chatting, I'll just show you the latency. It's pretty fast. And it also depends on the GPU that you're running it on. Because this is running on a latest generation GPU, so that's another thing.
What is the reasonable GPU recommend for a desktop copying video?
5080 would be a good point to start right now. 5080? Yeah. 5080 would be good. Like, again, it depends on your use case. Like, if you want to do something that is graphics heavy, so that's a separate kind of GPU. Something if you want to do AI heavy, we just released DGX Spark. It's a tiny box. Can also fit in your palm. And it has about 200 TOPS, which is an incredible amount of compute sitting on your desktop. So if you are planning to do anything AI related, that's the best thing right now for an entry grade GPU. Or 5080, 5090, these series also have AI cores now, but it is more focused towards gaming, towards content creation, mostly like powering your Premiere Pro and stuff like that. But if you want to do something AI related, the best thing to get it is a DGX Spark. So it will be released, I think, in India about in July time frame. It got introduced in GTC during March. It will be here next month. So this is how this was created. And this is where we do not want our end consumers to break their head. Because like it took us quite a while to build a pipeline like this. And that's the reason why we are open sourcing all of these blueprints. So you take these blueprints, and there are multiple of them. And this is a site I highly recommend anyone interested in AI. Please go to build.nvidia.com. You'll find a ton of blueprints. And with these blueprints, what you can do, essentially they are Lego blocks. You can connect them in the way that you want to create that final end product that you're looking at. Or else, if you think that this blueprint is enough and I can only tweak one part of it, let's say I want to add audio part to it as well, because right now it is just doing video summarization. If I want to augment it with commentary as well, like the commentary and the video goes hand in hand, you have this pipeline, just augment it with the audio bit. And for the audio pipeline, you also have blueprints. You have Riva, you have a lot of things that are demonstrated there. Both are open source. You can take them and you can start plugging them together the way you want. So it spares you with all the complexity and nuances of keep building a pipeline like this, testing and spending your developers' cycles. So these are all production ready, available for you to take home and run it on your GPUs. Now what we are showing is how AI is helpful in breaking your cultural barriers. What we are going to show is our lip sync model. Again, this is a lip sync 2D model, and there's a lip sync 3D model as well. So this is the same person who will be talking in 4 different languages. And anyone following Lex Friedman podcast over here? So you might be aware that there was a podcast by Honorable PM Modi and Lex Friedman. And in a couple of days' time, Sarvam AI, one of India's premier AI companies, they dubbed it in 11 Indian languages and released it. So Sarvam is one of our closest partners, and they took our lip sync model, fine-tuned it for their use case, and essentially they built on top of it. And that is how that video was created.
Welcome to GTC. We are thrilled to have you join us for this exciting event. Whether you are here to explore cutting-edge technologies, connect with industry leaders, or discover the future of AI, you are at the right place. Get ready for insightful sessions, inspiring speakers, and groundbreaking innovations. Let's dive in and shape the future together at GTC.
Bienvenue au GTC. Nous sommes ravis de vous accueillir pour cet événement passionnant. Que vous soyez ici pour explorer les technologies de pointe, vous connecter avec les leaders de l'industrie ou découvrir l'avenir de l'intelligence artificielle, vous êtes au bon endroit.
Bienvenido a la Conferencia Tecnológica de Gráficos. Estamos encantados de que te unas a nosotros para este emocionante evento. Ya sea que estés aquí para explorar tecnologías de vanguardia, conectar con líderes de la industria o descubrir el futuro de la inteligencia artificial, estás en el lugar correcto. Willkommen bei GTC. Wir freuen uns, dass Sie uns für dieses aufregende Event begleiten. Ob Sie hier sind, Spitzentechnologien zu erkunden, sich MIT-Branchenführern zu verbinden oder die Zukunft von AI zu entdecken. Sie sind am richtigen Ort, machen Sie sich bereit für.
So essentially, like simulating the lip movement, I really wish we had a better high quality display so you could focus on the lip movement. Like manipulating the lips with AI was a task that took the dubbing artist a lot of time. Now you can just have like a plug-in replacement. This model takes in your video, takes in your audio. It understands how the lip moves for different languages, and it can just tweak that based on the target audio that you're using. Absolutely. So Lex Friedman's video was done in 11 Indian languages. NVIDIA did not do it. Sarvam AI did it. Yeah. Sarvam was the first company that created India's large language model, and we were working with them very closely. And Sarvam and NVIDIA has a very close relationship, and they get early access to a lot of our technology since they are our technology partners as well, and they take it and build the use cases. Because we rely heavily on our ecosystem partners. Because NVIDIA is a platform company, we do not build the final product. We will never build the final product. What we do is we create the research, we create the tooling, we create the hardware, and essentially rely on partners to create the end solution. And
Mostly this is on camera facing, but if you're not facing the camera, you have a problem.
yes, so frontal, right now the limitations of this model is that anything that is having like a frontal view, that's easy to manipulate. Whenever there's a side profile, there's a bit of a problem. But again, advancements are definitely the lip sync 2.0 is exactly addressing this problem. Because for this model right now, if you want to use it, it's perfect with frontal facing view. So you can imagine like a broadcaster, TV broadcaster, any news anchor, they typically have this frontal view. So it's very good for them to transmit the message in multiple languages without having to have like a dubbing artist work on it for hours and hours. The dubbing artist now can rely on tools like this and cut down the time to air maybe from a few hours to a few minutes.
Multiple people also has problems.
No, multiple people, it works fine. Multiple people in the frontal view, it does an amazing job. But it's the frontal profile, it works very good. So if you have like a widescreen camera setup and there are multiple people, everyone is like having a frontal profile, it's fine.
Voice mimicking I'm talking about. There is a problem. When multiple people are there, voice mimicking is as a problem.
So these models, they also have like something known as the online speaker diaritization. What it does is isolates both the videos, and both the videos are taken to different streams. And those streams essentially, one stream would manipulate, let's say, speaker one lips, and the second stream would manipulate speakers two's lips, and then there's a fusion, yes. So along with diaritization, so that's absolutely not a problem. But yes, when your profile is a little side profile, we are working on that, and that's the problem that we are tackling next. So again, the pipeline looks something similar. So this is the Maxine lip sync model. So if you go to build.nvidia.com, you'll find Maxine, and you can just download it and start using it. Now we'll be showing you, okay, where does all of this converge for the media and entertainment industry mostly? And it converges for us mostly in gaming, because gaming is in NVIDIA's DNA. And all this, whatever we are creating, is taking your gaming experience to the next level. And over the next few slides, this is exactly what I'll be showing you.
Bienvenido a la conferencia.
Move. So, this. Can someone hit the play button, please? Yeah, it started.
We're thrilled to showcase an immersive and dynamic interaction between a player Kai and a non-playable character named Jin. This captivating ramen shop scene was created by NVIDIA using the latest RTX rendering technologies. NVIDIA collaborated with Convey, an NVIDIA Inception partner, to showcase how developers will soon be able to use NVIDIA Riva, Nemo, and Audio to Face for AI-powered speech, conversation, and animation. These models were integrated into the Convey Services platform and fed into Unreal Engine 5 and MetaHuman to bring Jin to life. Please take a look.
Hey Jen, how are you?
Unfortunately, not so good.
How come?
I am worried about the crime around here. It's gotten bad lately. My ramen shop got caught in the crossfire.
Can I help?
If you want to do something about this, I have heard rumors that the powerful crime lord Kuman Aoki is causing all sorts of chaos in the city. He may be the root of this violence.
I'll talk to him. Where can I find him?
I have heard he hangs out in the underground fight clubs on the city's east side. Try there.
Okay, I'll go.
Be careful, Kai.
What was unique in that? Can someone guess what was unique in that? Exactly. Exactly. So imagine you are playing a game where you can talk with the character, not sticking to a script or just picking some options. So that's how we envision that the gaming world is going to benefit a lot from this. And this is going to make gaming a lot more immersive. And not only like you can now talk to your characters, now your final boss, once you play a game, you know, hey, if I do these moves, I know how to beat this character. But now, this one, what I'll just show you. Now the boss also has a AI mind. It can understand your strength, it can understand your weakness, and it can anticipate your attacks, and it can also strategize. So that is again making gaming more immersive, and that is what I'll be showing you.
Welcome to Mir 5, the Mir series game introducing Asterion, the world's first AI boss monster built with NVIDIA ACE. A script-based boss monster follows predictable patterns, regardless of who the opponents are. As a result, players can easily anticipate and counter the boss's attacks, making the encounter less exciting and reducing it to a tedious task to acquire items. But Asterion is no ordinary boss. Artificial intelligence enables Asterion to analyze the player's information, identify unique skills of each player, and determine who to attack first. Asterion recalls past battles similar to the current situation. It then determines the most probable course of action to achieve victory. Asterion adapts, attacking with unpredictable patterns. It cannot be defeated twice with the same strategy. Welcome to Mir 5. Are you ready to face Asterion?
So that's another use case that's out there. This game was in the making and is about to be released. So you can imagine, like, if you just let your creativity loose, you have all the toolings to let you do anything that you envision you want to do. The next thing, again, like from where NVIDIA started. So it's in the name, N and the VIDIA. The VIDIA is for the video, and the green color was for envy, that we create a system or we create a chip that's so powerful, so unique, that the rest of the ecosystem is a bit envious. That's the history behind the name. And it came from generating graphics. NVIDIA started as a graphics company. The name, the GPU, you are training your AIs on GPUs. It's still called GPUs, Graphic Processing Unit. It was designed specifically for rendering graphics so that whatever you are seeing on the screen is as realistic as it can be. Now we have hit a point in graphics industry where things were kind of plateauing. So if you are playing a game or running a video at a particular frame rate, you could not go beyond that because the hardware requirements were growing so exponentially. So there were technologies such as rasterization and ray tracing, which essentially creates whatever you are seeing on the screen. But scaling that just by adding more compute is a process that was not sustainable. So that is where AI came to rescue us. And we created a system called DLSS. So DLSS stands for Deep Learning Super Sampling. So what is DLSS? So let's say one of the frames is what the GPU renders traditionally. So during the traditional rasterization and traditional ray tracing, you generate one frame, but what DLSS did was it generated intermediate frames which were artificially created. So on the device drivers, we had AI sitting which analyzed the frames and then created the next frame. So that was the first step in evolution for DLSS. Now we are in the fourth iteration. What we just launched is DLSS 4. Now for every frame, you generate 3 more frames. So essentially a game that you could play at 30 FPS at 4K, now that gaming experience can get elevated, let's say up to 80 FPS, 60 FPS. So you are getting free boost with no additional hardware cost. So that is what I'll be showing you next. Yeah. So this is where the entire story ties. So whatever I was showing you in the first part of the presentation in bits and pieces, so this is essentially where it all culminates. All the things that were created in isolation, they all come to create things like this. So that is what NVIDIA is doing, and this is where we invite every one of you to come explore AI with us it's a assistive technology that is only going to make you more and more productive. And we invite everyone in the ecosystem to come, try this, experience this, and make yourself and the work that you're doing more productive. Thank you. And if you have any questions, I'll be happy to take them now.
Let's say you want to build something, right? Now there has to be context between the first scene and the second scene. Is there a way to do that?
Yes. So what I showed you in the beginning, the video montage that I created, so that was a text to video path. But there are multiple pathways. So there's an image to video path as well. So you can just have your initial frame and then you have your text. Both of them, they work together to create the next sequences that you are. So you can have those anchor frames or seed frames to create the rest of the video for you.
Can I ask one? Sure. Without buying or purchasing a GPU, can one do some basic text to audio conversion?
You can. So if you don't want to buy a GPU, there's another model that's becoming very popular in India. So government is investing heavily in creating the infrastructure in PPE model. So there are cloud players like Yota, E2E. So they have done the purchasing on your part. What you can do, you can either rent out a GPU or they provide these as services as well. So you can take those services if you don't want to like initially get that infrastructure set up without exploring that the POC turns out the way it is. So you can definitely work with these cloud players, and GPU infrastructure is becoming more and more accessible in India now as a service as well. Yeah.
Yeah, it's very interesting to see this. As a cinematographer, I wanted to know what happens is now different cinema camera shoots in a different binary style. It's 4:2 and this one and all. So now what happens is, does the GPU understand if I'm using forced camera setup with different formation of pixelation, RGB, will this convert it to one standard master and come back with slow motion?
Yeah, I'm really happy you asked this question because I was at GTC and I was giving this exact demo 4:2:2 10-bit.
Exactly.
And in DaVinci Resolve, it takes and you can do all these renderings.
Yes.
So I also have a video. If you just have time, I can sync up with you offline.
Yeah.
Exactly, this was the demo that we showed, that there's a 4-camera, multi-camera setup where we actually simulated a podcast, 4-camera, multi-camera setup. It can be a 10-camera setup as well.
Yeah.
And then the different streams are going, and we have a stack for that called HoloScan that has been purpose built for doing exactly this.
Why I like it is that over a period of 20 years, now I understood why Panasonic was trying to create the intra-frame, iframes.
Okay.
So creating, because every time there used to be between 24 and 25. So they used to create an intra-frame.
Yeah.
Proxy file.
Proxy frame.
So what happens is the picture doesn't, it gives you proper interlacing.
Yeah.
Correct? So now this is a very beautiful thing where I wanted to know, since we're using 7-8 cameras, how do I make it and can it be streamlined and given a proper color corrections and whatever?
So color correction is also something that we showed as a part of that demo. I'll be happy to forward you that deck, the demo, as well as the stack that was being used.
Exactly, because what information I'm picking up from the camera, the lens data system, suppose if I need to create anamorphic or if it is a spherical and all, so it's a very beautiful session for me to get into bridging that and enjoy the filmmaking in a very simple and faster way.
I'm glad that you found this useful.
Yeah,
Thank you.
thank you.
I'll help you with the content. Yeah, sir.
Just in addition to your previous point on investing in hardware versus cloud, can you just give us some technical break-even point or indifference point? At what point somebody should consider investing in hardware versus going to cloud?
Okay. It's a very good question, and it's very difficult to answer as well, but I can just give you a back of the envelope, some calculation. Let's say you're building a POC. Probably 10, 50, 100 people are going to use it and evaluate that. That's a point you should go for the rental. But when you scale and you have like thousands or 10,000s of requests coming in per second, That's the point where you think where you should start thinking of having the infrastructure on-prem, or else your cost, the cloud cost, will just keep growing exponentially. So that's more or less like you start with building the POCs, the MVPs, you do it via these clouds. Once you have done and you have reached a scale, that's the point where you should invest in your own infrastructure.
So scale in terms of the number of requests, or even there are some technical parameters that these are the resource consumption?
More or less, you can think everything is correlated with number of requests coming in per second.
Got
So
it.
everything maps back to that.
Got it. Thank you. Thank you.
Any more questions? Okay, I think then we're good. Sure.
We have a few more minutes.
Okay. Sure.
Anish, I know that AI is going to bring a revolution, is bringing revolution. We had a few films, black and white films, which were turned into color.
Colorized,
Was that a labor of love, with every little detail being colored, or was it done through AI? Or in future, any more black and white films which would be turned into color films? That was Mughal Azam, I think, right? Which was converted into a color film. So any more black and white to be converted into color films? AI is the answer?
Yes.
Is it possible?
Yes.
Easy?
Very easy. So you have in painting and colorization models. So you just feed in the frames and the color comes out. So there are series that are being done. So you take the black and white frames and you have these in painting and colorization models, and they do it for you. So it's readily available.
Oh.
Yeah.
There are also pitfalls like voice cloning. We've had a few incidents all over the country where a child's voice is cloned and they say, "Aapka bacha kidnap ho gaya hai," or the child's. That's why they say, don't be very careful about what you're posting on the on the social media, because your voices can be cloned, your faces can, whatever, all that. So, is there any protection mechanism as of now? Either through the tools of AI or at the receiver's end, where this can be taken care of. There have been instances, child is crying and the mother says, "Oh, the child is saying, bachao, bachao, mummy, bachao, bachao," because the voice has been cloned and the kidnappers have a field day. Please answer that.
So there are a few mechanisms. So image detecting an image, whether it's generated frame or a real frame, that can be done using AI. Voice, sadly, these models have become so accurate, and voice cloning, just 5-second sample of your voice is good enough to clone your voice. So that is a little trickier thing to do. Again, we are working on those solutions as well. Everyone is using UPI, right? So NPCI is the company that's responsible for it. NPCI is doing at scale fraud detection. You can imagine billions of transactions happening every day. So that is again all being done using AI. So there are aspects of it where we are very good in preventing fraud. There are aspects of it where we are still catching up to the technology, how good it became. So it also takes the researchers time to kind of catch up to how good suddenly these voice cloning technologies became. I started doing AI in 2016, and the form it is right now in, I cannot even recognize someday that how far and suddenly how the entire world changed.
So in a court, now our laws are being changed. We have 3 new laws now. The whole system is being changed. Tough to pronounce, adhiniyam, and for witness, for many aspects of law, they are now revamped. Criminal code has been, Evidence Act has been revamped. So in a court of law, is it still a valid thing? You present a conversation. It could be cloned. Where does it stand in a court? If it's cloned, if it's not cloned, and you say you can clone voice, does it become very difficult for a judge to realize kya fake hai, kya real hai? Which world are we stepping in? It gives me a bit of a fear.
So I think I would leave that to the good sense of the judges. But I'll just tell you that what our judicial system, because that is again very close to my heart and I work very closely with these partners, and Supreme Court, as of last year, they have implemented system where they have sort of their own chat GPT, where they can search on all the historical proceedings. It tells you exactly, if you ask the question like, what was the weapon of murder, it will point you exactly in the judgment why was this judgment given. It can also reason and tell you the reason behind it. The court proceeding, everything is being transcribed in 22 Indian languages. So NIC is doing that, and I personally work very closely with NIC, and all the witness recording, whenever there's a proceeding and you have to record the witness, earlier you would need someone to just, a stenographer essentially, who would type things up in shorthand and then they create a report. Now you have these ASR model created by IIT Madras, adopted by NIC, deployed at judiciary. So you can think like the entire ecosystem, right from the start to end, everything is built in India. And we are working with researchers to ensure that these ecosystem has support. So, because when we started working with the judiciary, we found out that the sheer amount of cases that gets registered per day, it's insane. And if you don't have assistive tech, it's very difficult to make the entire pipeline efficient. So NIC was given this mandate, NIC developed this system, and they did implement it in Supreme Court, and they are in the process of making sure the other courts in the judicial ecosystem also get benefit out of this.
Yeah, because I do know that this revamping of laws has taken into consideration the technicalities and the digitized new India. But where does AI fit in? Since I'm not into law myself, I was just wondering, because they have figured it out. They have featured it. The whole evidence has been changed now.
They're using AI to kind of fast track the process.
Yeah.
And they're also in the process of, I think, figuring out what policy changes needs to be done at the policy level, at the legislation level, to make sure you're protected against it. So that is, again, that is where policymakers are the best fitted to do that. And that's the work, I think, that's been done in the parliament as well right now.
And when we talk of artificial intelligence, there are still people say that I always say that this is a country, if you remember the picture, iconic picture, the first rocket we launched was being carried on a bicycle way back. So I think this is a country where bullock carts and satellites coexist. So there is room for everybody under the sun. We are such a diverse population. There are still areas, pockets in our country where literacy hasn't reached. You think if they have not, if literacy hasn't reached the lives of many people, you think AI, in a way, will help them leapfrog? Bola, aa gaya?
Definitely, it will become a vector. And there are government agencies who are doing that. So the Ministry of Education, they have Anuvadini, where they take in they take in content and they convert it into vernaculars. There are missions which was started by the Prime Minister's office, like Bhashini.
Yes, Bhashini, the app which translates into many languages.
And it does a lot more than just the translation. So Mahakumbh was recently supported by the Bhashini services. So Ola was there. Ola, they created the RAG pipeline. The language part of the support was given by Bhashini. So the lost and found, like, they assist law enforcement, they assist the commoners. So everyone is getting benefit out of that. And the policymakers, they absolutely understand the diversity of our country. And that's why, like, initiative like Bhashini came into existence. And Bhashini, the scale at which they are growing is just incredible.
Absolutely. In fact, whatever we do, our scale is so huge that will be a case study for everything for a Harvard educated person. We have so many countries put together. So whatever we do, actually the scale is mammoth, and it's amazing the kind of work that we are doing. Thank you so much.